Talking about rational expressions, which really means the same thing as algebraic fractions. We talked about how to reduce them, like you used to reduce numerical fractions. Now we're going to talk about how to do the 4 operations with rational expressions or algebraic fractions. And it's just very similar to what we did with numerical fractions when you learned them in previous years. So let's look at multiplying first. So here's a question. There's no variables. It's just 2 numerical fractions getting multiplied. How'd you do it? You guys should know how to multiply fractions. No one? Really? Can't remember how to multiply fractions? You guys were multiplying fractions in the trig unit. Top by opposite bottom over bottom by opposite top? No, that's crazy. Okay, so you multiply the numerators, you multiply the denominators, okay? But back in grade 9, those of you that were here, I showed you something that you should do when you're multiplying fractions before you multiply the numerators and denominators. Simplify. How do we simplify? We take can I simplify any numerator with any denominator? Can I reduce? So I can take the 5 and the 15, and I can divide each of these by 5 and get 1 and 3. Is there another pair, numerator and denominator? 2 and 6. I could divide both of these by 2. 1 and 2. Now multiply the numerators and denominators. Hello, what? Oh, 3. Sorry. Thank you. So then we just go 1 times 1 over 3 times 3, which is 1/9. So you do the same things when variables are introduced, okay? You reduce, and then you multiply the numerators, and then you multiply the denominators. Except we have to do one thing, extra thing with algebraic fractions or rational expressions that have variables. First of all, I have to identify any non-permissible values. What values of x would make any of the denominators 0? 0. Like if I plug 0 in here, it doesn't matter what 3 and y are. This is all going to be 0 and I can't do it. Okay. What about y? Y can't be 0 as well. So we would want to say before we start reducing things, x and y cannot equal 0. Or you can write, well, no, don't, yeah, I would write it like that. NPV's non-permissible values equal 0. You could write it like that. Okay, so now what we've got to do, and I'm going to rewrite this to make it a little bigger. Because we're going to have to start reducing. Okay. Let's just look at the numbers first, and then we'll deal with the variables after. Is there a pair of numbers, one in the numerator and one in the denominator, I could reduce? Which ones? I could divide both of these by 4 and get 1 and 2. What about the x's? How many x's are getting multiplied up top? 2 of them, because it's x squared. How many x's are getting multiplied on the bottom? Sure about that? 2. 1 here and 1 here. So if I'm multiplying by 2 x's up top here, and I'm multiplying by 2 x's on the bottom here, I can reduce them all. They all reduce down to 1. What about the y's? can I reduce any y's? Well, there's one y down here, and there's two y's being multiplied up here. So can't I reduce one of them? And if I take away one from here, then I'm left with y. If I use one of the y's in y squared to cancel with the y here, I'm left with one y here. That's everything. So what do we end up with? 1 times y, which is y. And the bottom, 3 times 1 times 1 times 2 times 1, which works out to 6. Okay. Now we get into the bigger ones. So these are much bigger expressions. What I want to do when I encounter expressions like C and D is, in order to find out what to reduce from the numerator and denominator, everything has to be in factored form. Okay, so we need to factor first. So you got to remember your factoring skills, because you can factor all 4 of these. X squared minus x minus 12. Well, that's 2 binomials, x and x. And then I got to figure out 2 numbers that add to -1 and multiply to -12. -4 and +3. The first denominator, this is a difference of squares. Well, difference of squares means we're going to have plus and we're going to have minus. The first terms are going to be the square root of x squared, so x and x. And the second terms are going to be the square root of the second one in the original, 3 and 3. The second denominator is like the the second numerator is like the first numerator. I can go down to 2 trinomials, x and x at the beginning. This time I'm looking for 2 numbers that add to -4, but multiply to +3. -3 and -1. And finally, the last denominator, well, it looks close to a difference of squares, but it isn't, because this isn't a perfect square. So the only thing left is GCF. So I can factor out an x, and I am left with x minus 4. Before we start reducing, before we start canceling things out, we need to state the restrictions, or state the NPVs. Okay? All the values of x that would make any of the denominators 0. So I'll go through each factor. What value of x would make this 0? What value of x would make this expression 0? So that's a restriction, a non-permissible value. What about this one? 3. Don't forget about this one. Don't overthink, it's easy. 0. And this one. So those are all restrictions. Now start reducing. Well, just look for identical factors. Those can go. The x minus 3s can go. Can anything else go? The x plus 3s can go, even though they're in the same fraction, they can still go. So I could take out a whole bunch of stuff here, and all I am left with at the end is x minus 1 up top. You can put parentheses, you don't need to. And x on the bottom. And that's as far as you can go. You cannot reduce these. Okay, I know the temptation is there, but remember, this is not x, this is x minus 1. In order to reduce this with a denominator, there has to be an x minus 1 down here. There isn't. So you can't reduce those. Because you've got to think of the x minus 1 together in parentheses. You can't pull out part of it. Okay. D is very similar to C. So you got to know your factoring. I'm not going to write the steps out. I'm just going to go. Come on. So we're going to factor first, whatever we can. How about the first numerator? Yeah, so it factors to a plus 5, a minus 5. First denominator? Well, it's not a GCF because it doesn't have anything the same in both terms. It's also a difference of squares. It factors down to a plus 1 times a minus 1. Second numerator, GCF, all we can do is take out an a and we're left with a minus 1. And the second denominator, well, we can't factor. There's no factoring we can do to it. And that's going to happen sometimes. And remember, whenever you have more than one term, treat them like they're together. And how do you treat them like they're together? You put parentheses around them. Okay, next is to state the NPV. So A cannot be, and then run through all the bottom factors. So A can't be. Five. So A cannot be -1, +1, or 5. -1, +1, or 5. Now we're ready to reduce. Give me a pair I can reduce. Yeah, those can go. There is another pair, and you have to remember what we did when we were reducing these things in the last lesson. It was a special case. Yep. If they're reversed subtraction, they can reduce to -1. So you got to put -1 with one of them. It doesn't matter if you put it up top or on the bottom. I always just put it up top. If you put it on the bottom, it's still correct. So we're done. What do we have up top? We've got a -1 times a, which is -a, and we're still timesing that by a plus 5. And on the bottom, we just have an a plus 1. Very important. Save yourself some time. You never have to multiply through. You can leave it like this. Okay? Leave it in that form. You don't have to make this -a squared minus 5a at all. So this is as far as we can go. There's nothing more to reduce. Because I've got an a here, but I don't have an a down here. This is not an a. This is an a plus 1. I've got an a plus 5 up here, but there's no a plus 5 down here. And I got an a plus 1 down here, but there's no a plus 1 up here. As far as I can go. Okay, so now that we know how to multiply, the next operation we're going to look at is division. Why? Because whenever we divide fractions, we change them to multiplication. And then we just do all the multiplication that we did on the last page. So for this first one, as just a review, because there's no variables, how would I write this as a multiplication? 5 over 3 times the reciprocal of the second fraction, or flip it, 6 over 1. Now we're back to multiplying. Now we're back to reducing. Is there anything I can reduce? 6 and 3 can go down to 2 and 1. 5 times 2 is 10, over 1 times 1 is 10 over 1, which is just plain old 10. Okay, let's introduce some variables. We don't have to factor anything here in this one. But one thing you've got to do with division is you've got to state NPVs twice. When it's in division form and when it's in multiplication form. So I don't need to factor anything. So let's state any NPVs right now. What can't, give me a restriction, an NPV. Oh, X can be 0. Y can't be 0. Now let's change it to multiplication by multiplying by the reciprocal of the second fraction. Now I got to state restrictions again because I have something new down below. What's another restriction? X can't equal 0. Now reduce whatever you can.
So you don't have to state y again if it's the same.
Yeah, because we don't have to state y not equal 0 because we already did it up here. This was the only new thing that happened. Down here? That's fine. But be careful because you don't want to miss any restrictions. You don't want to miss any non-permissible values. So what could I reduce? Yeah, I could divide each of these by a y. So I'm left with 1, and I'm still left with a y down here. I could do the x squared in x. So x divide x is 1. X squared divide x is x. So I'm left with 3 times x times 1, which is 3x, over y times 1, which is y. All right, these next two, they're going to take a fair amount. So we got to, because we got to remember everything we need to do. Before I want to start stating NPVs and flipping and reducing, I want everything factored. I'm going to leave it as a division question. First numerator is a difference of squares, x plus 2, x minus 2. First denominator is a GCF. I can take out x and be left with x minus 4. And the next numerator and denominator are both trinomials. Anybody got the first one? The top one? X plus 3, X minus 2. And the bottom one, X plus 5, X minus 4. Okay, so everything's in factored form. Now, before I change to multiplication, state restrictions, state NPVs. So run through all the denominators. What can't X be here that would make this 0? And 4 again, I don't have to write the 4 again. So X cannot be 0, 4, or negative 5. Now let's change it to multiplication. First fraction stays the same, except now I'm going to multiply by the reciprocal of the second, so I'm going to flip the numerator and denominator. Because I did that, I made a new denominator, which means there are more restrictions or non-permissible values. Well, nothing changed here in the first one. We still have 0 and 4, but there are a couple of new NPVs in the second one. What can't X be here? And 2. The 0, 4, negative 5? No, because you've already stated it. What? I couldn't hear what you guys were saying.
You said they just asked the same thing.
Did you?
Yeah, I did.
Oh. How about that? All right, let's go crazy. X minus 2s. X minus 4s. That's as crazy as we can go. So our final answer is X plus 2 times X plus 5. You don't have to multiply them through. Leave them as that. Leave them in factored form. And on the bottom, I've got X times X plus 3. Again, don't multiply it through. I mean, if you multiply it through and you do it correctly, it's still correct, but it's unnecessary. You don't have to. Because how do we simplify these things? We always want them in factored form without multiplying through. Okay, last one. Get everything in factored form first. First is a trinomial, first numerator. First denominator is a difference of squares. Second numerator is a trinomial. And the second denominator is GCF. Anybody got the first one? Negative 7 plus 1. First denominator? P plus 7, P minus 7. Second numerator. Plus 7 plus 1. And this is a GCF, so I can take out a P and be left with P plus 7. NPVs. P cannot be 7, negative, so negative 7, 7, and 0. Now let's change to multiplication. By flipping the second fraction. I've got a new denominator, so I've got to possibly add to my NPVs. Well, I've already done -7, +7. I've already done -7, but this is new. -1. Now we're ready to go to town. P plus 7s can go. P minus 7s can go. P plus 1s can go. And that's as far as I can go. So I am left with P on top and P plus 7 in the denominator. Looks like a lot, but you've got all the skills to be able to do it. Just got to remember everything you got to do, the steps, especially with the more complicated ones that you have to factor first.